Hello there, mathletes. Alright, today is 13.2 and today is Radian Day. Radian Day. Now, I don't want you to write anything yet. Put your pencil down for a minute and just let me talk for about 30 seconds and then we'll pick them up and get going. Now, if you think about it, how we measure angles is kind of stupid. Alright, we say, let's say this is 60 degrees, right? This is a 60-degree angle. Well, is this 60 degrees? Or is this 60 degrees? Or is this 60 degrees? It really doesn't make much sense. All right, and so some dude came up with something that says, well, let's use radian measures. And what radian measures is it's a unit circle. So some dude drew a circle on a coordinate plane with a radius of 1. So this is positive 1, negative 1, negative 1. And he goes, well, let's measure angles where they cross this circle. So if that's 60 degrees, he says this would be 60 degrees. Okay? And what's awesome about radians is if you think about it, a full circle, they say, is 360 degrees. Well, base 360 degrees, who comes up with that? All right? It's just... I'm good working with 10. I'm comfortable working with the base of 100, but 360, it's not nowhere. So this dude uses base 2. All right, so now a full circle is 2 pi. All right, so now everybody pick up your pencil and let's formalize this. So what radian degree measures allow us to do, and it's based on the unit circle, which we'll get into later. But for now, again, this direction is still positive. All right, if we're moving this way, it's positive. This way is negative. All right, however, we're using a different measure now. So this would be said to be 0 degrees. All right, and a full time around we say is 2 pi degrees, or just 2 pi radian. All right, so this is base 2. All right, so if this is if a full turn is 2 pi, then half a turn is 1 pi. All right, which means this is kind of 0.5, right? Halfway between 0 and 1. So we say 1/2 pi or pi over 2. 1 pi over 2. And then this is kind of like 1.5. So we call this 3 pi over 2. All right, so now we're dealing with base 2 and we're tacking on pi. So a full circle is 2 pi. All right, and then if we're trying to find out coterminal angles, remember yesterday we did plus or minus 360. Well, today we're going to do plus or minus 2 pi. Now, I love radian measures. All right, and they're really, really good. The only difficult part is we have to be comfortable working with fractions, and we all know how much you guys love fractions. So let's do some. So for this angle, for this exercise, we're going to draw /graph our radian measure, and we're going to list our two coterminal angles. List 2 coterminal angles, and just like we did yesterday, we want 1 positive and 1 negative. All right, remember how we added 360 or subtracted 360 and we kept going until we were all out of options. All right, so let's start with let's draw 3 of these things. 1, 2, 3. All right, so the first one we got, let's start easy, is pi. All right, well, we know a full turn is 2 pi, so starting at here to here is 1 pi. All right, so my radian measure is 1 pi. Now let's do my coterminal angles. So that's my graph, part 1, check. Part 2, so if we take 1 pi and we add 2 pi, I get 3 pi. So that's my first coterminal. So if I went all the way around and then 1 pi more. Now if I have 1 pi and I subtract 2 pi, I'm left with negative 1 pi. So there's my positive coterminal and my negative coterminal. Pretty easy. All right, now let's have some fun. I'm going to go 12 pi over 5 is my radian measure. Now, This is how I like to do these problems. Let's work with fractions we're comfortable with. My denominator is 5. So how do I represent 1 pi? Well, 5 over 5 pi. 5 pi over 5 is 1, right? So what would be 2? Well, 10 over 5 is equal to 2. So 10 pi over 5. Now I use those as my guide. All right, I use those as my guide. So here I start here, 5 pi, 10 pi. Now I need to go 2 more. Now think about this. Between 5 and 10, okay, is like 2.5, right, or 7.5. And I need to go 12. So I'm going to go almost here, but not all the way. All right, so I went 5, 10, and 2 more. All right, with this being like 2.5. Right, because it starts at 0 pi, 2.5 pi, 5 pi, 7.5 pi, 10 pi. So 12 pi would be in there. Now, so we started with 12 pi over 5. All right, so to get my coterminals, I either need to add or subtract 2 pi. Well, let's subtract 2 pi. Well, in order to subtract 2 pi, I need a common denominator. Now, in your calculator, you can go 12/5 minus 2 math frac, and it'll give you your answer. But just to show you why, remember, we need a common denominator. So 12 pi 5 minus, to get a common denominator of 5, I'd multiply that by 5, 10 pi. So negative 10 over 5 pi is negative 2 pi over 5. 12 minus 10 is negative 2. The denominator stays the same. So that's my negative 1. All right, now I got to get a positive 1. All right, well, I could take, oh, I'm sorry, that's positive 2. My bad. So that's my positive 1. I was wondering why I was startled there. All right, so then to get my negative 1, I would have to subtract 2 pi again, and that actually gives me negative 8/5 pi. All right, so there's my positive 1, there's my negative 1. Again, just use your calculator. All right, then over here, let's twist our brains up a little. 39 pi over 7. Haha. All right, well, I'm going to move this over just because I ran out of room. Yours should be okay. Okay, so my denominator is 7, so I'm going to call this 7 pi over 7. And this is going to be 14 pi over 7 to represent 2. So starting at 0, I go 14, 28. Now if I do another 14, that brings me at 42. So I don't want to go that far. So 28 and 7 gets me to 35. Okay, so here I'm at 35 pi over 7. All right, now, from 7 to 14, halfway through is, right, 10.5. All right, halfway through is 10.5. So I got to go a little more. So I went 35. Okay, so 39 is going to be past here, right? Because from 35 I had to go 4 more. 4 more would put me at 11. So I'm like right there. Right? Because 4 more would put me at 11 pi. So that's that. Now, my coterminals, all right, if I add 2 pi, I'm sorry, let's subtract 2 pi. I'll probably still get positive. I get 25 pi over 7. So that's 39/7 minus 2. If you minus 2 again, you get 11 pi over 7. And then if you minus 2 again, you get negative 3 pi over 7. There's my negative, there's my positive. All right, so it's not difficult, you're just dealing with fractions. So it can melt your brain a little. All right, so now that we're comfortable graphing and finding our coterminals, let's talk about reference angles. So yesterday we did reference angles. We're going to do them the same way. Draw and state reference angles. The only difference is now we're dealing with radians. So again, I'm going to draw 3 of them. 3 examples and we're done. 1, 2, 3. Now, this is the really, really important skill here. So let's go 3 pi over 5. I have a denominator of 5, so we're going to say 5 over 5 pi, 10 over 5 pi. All right, if some people like to label this 2.5, 7.5, just to help you carry through. So I have 3 pi over 5. So I got to go 3 pi. Well, I know 3 is more than 2.5, right? So I'm going to start here, and 3 is about there. Now, the way I like to think about it is what's left over. Remember, the reference angle is always in relationship to the x-axis. How far am I from the x-axis? It's always positive. What's my closest distance to the x-axis? Closest distance to the x-axis. That's how we got to think. So I'm talking about this distance here. All right, well, I already went 3. So I went 3 pi. How many is left over? Well, to get to the x-axis, there's 2 left over, right? 3 and 2 make 5. So my reference angle is said to be 2 pi over 5. Because 2 is left over, your denominator stays the same, tack on pi. All right, so to get to the x-axis, I would have had to go 2 pi more. All right, let's try a negative one. Let's try negative 3 pi over 2. Again, I have 2 over 2 pi. This would be 4 over 2 pi, 0. So from 0 to 2 is 1, and from 2 to 4 is 3. All right, but we're going backwards. So from here to here is negative 2. Then negative 3 would be 1 more. So I would stop here. There's my angle. Well, to get to the x-axis, I would have to go 1 more. So my reference angle is 1 pi. My denominator is 2. All right, see? Just fractions, not so bad. All right, how about 13 pi over 8? 13 pi over 8. All right, so I have, again, I'm going to move this over, lo siento. 13 pi over 8. So I have 8 over 8 pi. I have 16 over 8 pi. 16 pi over 8. All right, and I need to go 13. Well, what's halfway between 8 and 16? Well, that's 11 pi over 8. All right, and I need to go 13 pi. Okay. So here's 8, here's 11. Now, I'm sorry, that's not 11. 8 and 16, there's 8 in between, that's 12. My bad. So 12, so 13, I got to go 1 more, so a little further. Now, I went 13. How much is left over? How much is between 13 and 16? Well, 3 is left over. So my reference angle would be 3 pi. Your denominator stays the same, which is 8. All right? Whew, that was fun. I like radians. Now, we're going to talk about this more tomorrow. But what I want you to do is give me the reference angle for negative 52 pi over 11. Tomorrow in class, we'll start with that, and I'll take all the questions and really make sure we got this moving forward. All right, see you tomorrow.